Hello, welcome to my channel, or welcome back. I see I have a lot of new subscribers. Thank you so much. I just hit 300. That's exciting for me. Honestly didn't think I would be like talking about, oh look how many subscribers I have this soon, but whatever. I'm glad people are liking the videos. I'm going to hopefully keep doing them. Not hopefully, I will keep doing them. Today, I continue to work on my my game engine off of video. I will just do what I did last time. Kind of go through what I worked on. And then, as per usual, I'm going to the gym. I have my pre-workout in my Hello Kitty mug. No stim, because I've already drank 2 Celsiuses today. And I was actually discussing with my friends, I think that's how I'm gonna die, is I'm gonna drink too many Celsius and then keel the F over. But let's hope that doesn't happen. Until I'm like 39. At that point, just, I don't know, just let me die. Anyway, so, what I have been working on, where is my mouse? So, it is quite a bit different than last video, I will say. So I'm just gonna go ahead and, oh dear. I'm just gonna go ahead and run it and show you guys what we got. Look at that, a box that you can go around there. I implemented mouse and keyboard movement. And before, I think last video, it was not a cube, just a square with the smiley face on there. So I got rid of the smiley face. And so these look like the same texture, but they're actually not. They are 2 different textures layered on top of each other. I will show the code for that. But basically there's one texture for a more what's called a diffuse reflection. So that's like a rougher texture where it doesn't directly reflect the light that hits it. It kind of scatters it in different directions. That's why rougher things tend to look more fuzzy. And then the texture on the outside is actually a metallic texture, so it's more shiny, to represent something more more smooth. So smoother surfaces, when light reflects on it, it kind of goes and reflects at a more perfect angle. So that's why mirrors tend to just reflect the light right back. But something more rough will scatter the light in different directions. So like my, I don't know if I'm gonna be able to show it. Oh dear. My ThinkPad is more rough. And the reason it looks fuzzy is because when the light hits it, it scatters in different directions. Just a little math and physics for you. Oh god, I lost my box. But yeah, I will go ahead and show how that's implemented. Also, we have some light sources. So if you notice, as I move around, the light reflects in different directions. I have about 5 light sources, I think, in this scene. 1 directional light, and then 4 point lights. It's hard to tell that because I only have 1 box. If I had multiple boxes, it would be kind of easier to tell, and maybe I'll throw that in the next video. I love drinking out of Hello Kitty's head. Cat brains. Yummy. Tastes like creatine and pre-workout. God, very stupid. All right, so let's take a look at the main file. So this is quite a bit different than last time. I'll just go down So we have the screen width and screen height. That's the same as last time, but I have these structs to represent lights. So in my engine at the moment, there's two types of lights. There's a directional light, which represents a light that is technically infinitely far away. So that type of light would represent like the sun. I know the sun is not infinitely far away, but as far as it is, it might as well be. So it hits everything at the same angle. And then a point light is something closer. So you give it a position. A directional light only has a direction. So we use that direction and it hits everything from that direction. A point light will actually have a position and the light shoots from that point to different to hit the different objects. But they are they're implemented somewhat similarly. But the point light has a little bit more stuff because it has to deal with the distance each thing is far from. The directional light doesn't care because it's might as well be out in the ethos. I don't know what that means. Why I said that. And here we have our vertices. It's the same as last time, except the new vertices have normals. Normals are just a vector that tells you what direction it is facing. So the box, actually, it'd be easier if I explained it with the game running. So with this box, all the normals would be pointing outward from the box. So if you have that surface there, like the outside of my hand is the outside of the box, the normals point perpendicular away from it. That is just to using light calculations amongst other things. So it's nice to have that information. It makes stuff easier, so you're not calculating it on the fly. You can calculate it on the fly, but any calculation you do in a game engine is just going to take up time. Yeah, and then we have a class for the camera, and we just pass in the initial position that will move around. This stuff here is the just an initial position for the mouse, and to tell OpenGL like this is the first mouse. Well, not OpenGL, to tell the program. OpenGL doesn't know about this, but basically we want to center it on the first mouse move, and then after that we set that to false. And then we also have delta time and last frame for calculating the time in between frames. Here we just have, I added some more things for implementing the key presses, basically checking if you hit W, S, A, or D, move around, and we update the camera with each key press. Typically in game engines, instead of moving the actual camera, you move the world around the camera. So that's kind of what's happening here when you move. We're recalculating all the transformations that we apply to the objects in the scene. So basically, yeah, you're moving the box, not the actual camera, but it looks like the camera's moving and the box is stationary. This is just to handle mouse movement, and this is to handle mouse scroll. I actually didn't even demonstrate the scroll. So yeah, oh god. Sometimes I move too fast right away and then I lose the box. But basically you can scroll in and out. It's really not all that interesting. Yeah, this stuff is the same. The only thing I added was adding debugging, so it'll tell me if there's an error. And I just realized I'm not using those constants that I created. So we're gonna do that. Oops, nah, this should be width. So that way when I change them, they'll be actually used. And then this is just a function that reports errors. Here we're enabling a depth test, which basically allows OpenGL to know what is closer and farther from the camera. That way it can layer things appropriately based on the Z position. So basically, if this wasn't there, it would not know. It would just like show things in the order they're rendered, and we actually want to show them based on their position, not in the order they're rendered, because we don't know what will get rendered first, second, third, whatever. And these are just setting those callbacks that I had up there. This hides the cursor. This is the same stuff as last time. We're just sending the Vertex data to the Vertex shader. Here we are setting those two textures. The one is a diffuse texture, one's a specular texture. The reason we have those two textures is just to have the light interact with it differently. So one is shinier than the other one. And then we pass those to the fragment shader. And then I'm also sending the number of point lights. Up there I have 4 point lights. There's probably a better way to do this. I could probably just have them in an array, but I will fix that later probably. I was just trying to get it to work. I was struggling a little bit off camera to get it to work properly. I noticed it was really just a bunch of typos, but once that is also a thing with game development. I feel like their typos will not make your game crash so much. It just makes stuff look wonky, which stinks and is harder to debug. Crashes are quite easy to debug. I thought it hurts. Supposed to be meeting my friend at the gym. Okay, well, never mind. My friend just texted me that he is gonna be late, so I got more time to talk to you guys. Perfect. Let me text him back. Oh, we're all right. Yeah, so where was I? Yeah, so here, inside the game loop, all we're doing is we're getting the current time, we're casting it to a float, and the time is just a counter from when GLFW started counting. It starts when you run the app and just increments every, I believe, millisecond or something. And then to get the delta time, we take the current time minus the last save time, and then we set the last time to the current time. And then from there we process the input. And in there is where we use the delta time. Delta time is just something that allows the game to kind of normalize for different timing of frames. So like most games run at 60 or 30 or 120 frames per second, but that's not always going to be the case because some frames could take longer to render, some could take less. So if we didn't have that delta time, the game would run slower on slower computers and faster on faster computers. What delta time does is we multiply that frame time by whatever amount we're changing the position, whatever, your character movement, your camera movement, whatever. We want to multiply it by the delta time, so it's kind of normalized on all computers or game systems, whatever. So, and let's see. here we are just setting we're setting a gray background here. And this is setting some buffer bits to just pass some settings to OpenGL. Here we are setting the camera position on the fragment or the vertex shader. Here we're setting the shininess of the material we passed in. This number is just a number that I was told in the book to use. If you wanted something more shiny, you could use a different number, or less shiny. One thing I'm learning is game development is you kind of just mess with things until they look and behave how you want, which I think is a little freeing. It's fun. I kind of like it, as opposed to like app development. Yeah, and here we're setting the directional light and the point lights on the fragment shader to be used. I just have a helper method on the shader class or struct to set those. Here I'm just getting the window size because it's it could be changed. So I use that to set the matrices that we use to transform the objects in the scene. I could okay, so this part is a little complex, and I'll just trigger warning math. Okay. So to move things around in 3D space, one of the simpler ways to do it is to use matrices. Yeah, I'm not that great at linear algebra. Most people aren't, to be completely honest. I am starting to understand this stuff, but not enough to explain it in a YouTube video. I'll be I'm gonna keep it creamy with you. I'm not an expert. But what I do know is I need to pass in the aspect ratio, and I get that by grabbing the size of the window and passing it into a GLM function. Okay, so a lot of the matrix math is luckily done by the GLM library, which is a math library brought to us by the people who made OpenGL and Vulkan. So thank you Kronos Group. I don't want to have to do the math, but this function just returns a matrix that will project the object in a realistic perspective. There's two different ways you can project an object. You can use an orthogonal projection, where things farther away from the screen don't look smaller, or a perspective where things farther away from the screen do look smaller. So if you're doing a 3D game, usually you'll want to use a perspective matrix. But for example, a game like SimCity uses an orthogonal projection. If you look at it, that like isometric view where everything is like the same size, that would be an orthogonal projection. If you wanted to do that, it's just a stylistic choice. I'm going with perspective because I'm learning. But maybe one day I'll do a little isometric game. Sonic 3D Blast, that's one that would use that. Although that game's not actually 3D, but it appears 3D. That had my ass fooled as a kid. I was like, oh my God, Sonic's in 3D now. Wow. This game sucks. That game sucks. But the soundtrack though, that is a great soundtrack. That's one thing you can guarantee with a Sonic game is the gameplay may suck. It often does, but that soundtrack, it always go hard as heck. I'm obsessed with Sonic the Hedgehog. Don't tell anyone, but my YouTube channel used to be called Maddie the Hedgehog. But I changed the name because I didn't want people to think I'm a furry. I'm not a furry. Not that there's anything wrong with that. I don't kink shame. I do kink shame a little bit. But y'all have fun. You do you. I'm not judging. I'm not judging. Let's change the subject. Okay, and the next thing is the view matrix. So the view matrix, basically, I forget actually what this does. Oh dear, I just have. Okay, let's actually look at the camera class because I don't actually remember. Let's take a look at the camera struct. So what does view matrix do? Okay. Oh, all it does is pass a GLM function. I think I should take that perspective function and just put it in the camera struct. I feel like it would be a little bit cleaner, easier. I'm not sure why the book had it had you write it out in the main function, but this one is in the camera class. I don't know why. I think it's just a choice that the author made for no reason. But anyway, this function it just returns another GLM, another matrix that basically tells you what you're looking at. So that's why it's called look at. And then you pass in the I, which is the camera. So you pass in the position of the camera, and then the center, which is the position of camera plus where the front of the camera is, like where you're pointing, and then you pass the up vector. These are all vectors on the camera class that you update with each movement. I have a method called update camera vectors, which just updates the front, right, up vectors. I'm not doing a good job explaining it, but I don't want to. Okay, so I don't want to pull a cyber shell, another Sonic reference. I don't want to pull a cyber shell, but like if you want to understand what I'm talking about and all this code, you gotta read the book yourself. I'm sorry. It's free. It's online. Learn opengl.com. I am not an expert. I am just vibing. That's all the channel is. I'm not teaching, I'm vibing. But I hope that it's at least helpful to see that you can also do these things. Okay, from there, we create a model matrix, which is another matrix that we use to move, to position things. What we're doing is we're passing, after we create these matrices, we are passing them to the Vertex shader, and I will show that shader in a second. And then we are multiplying them by the position, and by multiplying all these together, we are able to position everything on screen. And that's where it comes from, where I said the camera itself is not moving, but we're moving the world around the camera. And that's what these matrices are doing. So we just are taking this matrix. This is the projection, view, and model are the names of, just like the traditional names of these matrices. You use these three matrices to basically move things around. So we're taking the model matrix and we're translating it by nothing, and we're rotating it by, again, nothing, and then we are, these are just the initial values, they change as we move. And then we're, well, actually they don't change because they're being set every frame. But because my box is in the middle of the screen, that's why it's 0. If I was to like change it, so if I change this to like 20, you will see it will actually rotate the box initially. And then, but yeah, after that we rotated by that angle and a view. I don't know what this V stands for. I think that's the view, whatever. Anyway, so if I leave that, I change the angle to what's it called, to 20 degrees. If we look and run it, look, it's rotated. Wow, amazing. And then we can again move ourselves around, but I'm gonna leave it at 0 because I want it to be straight when it starts. Okay. So I will show you the the shaders. So keep those in the resources. So we do the vertex shader. That one's much simpler. Vertex shader, we're just passing in that vertex data, which is the position, normal, and texture coordinates, and then we're just setting them to new new variables that we're gonna pass to the fragment shader. And then we also pass in those 3 matrices, and we multiply the model matrix by the position, and we have to cast it to a vec 4 and then cast it back to a vec 3. And then we grab the normals, which we also multiply by the model, but I don't remember why we have to transpose and inverse it, to be honest. I think it's because because it's going the opposite direction, so it's like pointed out. I believe that's why, but don't quote me on that. I have to reread the book, probably. I didn't actually reread the book because I was building this. I skimmed it. I'll be honest. If you're reading the book, you don't skim it because you're new to it. Unless you're not. If you're not new to it, if you're not new to this, you're true to this, then just skim it. And then lastly, we set the position to the projection times the view times the fragment position that we set up here. And you have to do it in this order: the projection times the view times the model. Matrix multiplication is not I don't remember. No. Maybe not. Whatever. You have to do it in the same order. It's not like multiplying scalar values. Like 1 times 2 is the same thing as 2 times 1, but with a matrix, it's not the same. Anyway, so the order matters is what I'm trying to say. So the order matters. And then let's take a look at the fragment shader. So fragment shader, we have a struct called material, and that just has diffuse and the specular maps that I passed in, and then that float value for the amount of shininess on the specular map. Then we have a struct for a directional light and a point light. They're mostly the same. The difference is they have like these values, constant, linear, and quadratic, which basically tell you how intense the light is and how it drops off over a certain distance. I'm just using some numbers I got from learnopengl.com. If you want your light to behave differently, you would mess around with those numbers. And then we have those 3 things I passed from the vertex shader, and then we have the out, which is the fragment color, and then we have more uniforms, which is the camera position, the directional light, which is the sun, basically, the number point lights, and then an array of point lights. I just made the 16 because I can't like put number point lights here because it's not a constant value. I want it to be somewhat flexible, and at the moment I don't think I will have more than 16 lights, but if I do, I would change this. And then we just have pass in that material. Here we have a function for calculating directional lights. I could go through this math, but you should just read the book if you care. It's not interesting. It's boring. But we take those two calculations. So we calculate the directional light, and then we do a for loop, and we add the calculation of each point light, and then we take that result and set it to a frag color, and like those all that light combined together creates the final color, because light is just color, or color is just light reflected. Delicious. My friend is like constantly late. So I'm probably just gonna go to the gym, and when he gets there, he gets there. He said 7 o'clock, but knowing his ass, it's probably gonna be like 8. And your boy has to get his pump. It's bench day. I actually started doing a program, kind of a program. It's not an actual program, but I am trying to be more consistent and improve my bench and deadlift strength. So I'm increasing my frequency and also picking day. I guess it is a program, but I've decided that I'm going to bench every week, 3 times a week. I'm benching Sunday, Tuesday, and Thursday. And I'm going to deadlift on Monday and Friday every week. And the goal is to achieve a 405 bench and deadlift. I will keep you updated on that. We'll see. Right now, I think my bench max is like 265. I think is the highest I've done, but that was like probably a year ago, and I've not been super dedicated to it. So hopefully I can still do that, but I don't know. I might try to max out today if my friend shows up and can spot me. And then my max deadlift is 315. So the 405 on the deadlift seems a lot more doable. And I have done 405 on the Smith machine deadlift, but not regular deadlift. So increasing the frequency, and then other exercises I'm just gonna do just like around that, and then rest on Wednesday and Saturday. So hopefully this makes a difference, because I feel like I have not been getting stronger. So hopefully actually being consistent will make me actually stronger, and I'll be like a power lifter or something, power builder, whatever. But yeah, that is my goal. Not that you asked. But yeah, that's where the engine is at the moment. I want to implement loading of 3D models, and from there I'm going to start working on some of the more advanced OpenGL stuff. This is the so-called basic chapters of the learnopengl.com. I'm undecided though if I do want to use like the same model loading library as the book, or if I want to do something myself for fun. And also, like, that library is just, it's a lot of boilerplate, and it's just like, I don't know, it took a super long time where I was just like writing in lines of code, not knowing what they do, and I hate that. So I would like to understand it. So maybe I'll just like pick like a simple 3D model format and try to parse it myself. But I don't know, maybe that's a bad idea. I mean, it is a bad idea. I know it's a bad idea, but I'm not one to do good ideas. I don't like good ideas. I like bad ideas. But yeah, I need to go to the gym. The pre-workout is coursing through my veins. I am really, I just want to. All right. I'll see you guys in the next video. Or, well, I don't know. Maybe, I don't know. I think, yeah, this video's got long enough. I will see you in the next video. Okay. See you at the gym, though. I was on the damn phone.
Okay, before I end this video, I have to talk about something horrible that happened at the gym. So when I was benching, this dude asked me to spot him, and so I did. I helped him. He was very nice. Gave him a little fist bump after the set, and we went our separate ways. And then as he was leaving, he said bye to me as I was doing the chest fly, and he was like went to give me a fist bump, and we both missed, and we just touched thumbs together. It was weird. And like neither of us wanted to adjust it, so you just kept walking, and I didn't know how to address it. It was a strange moment. So yeah, that happened. It was awkward. Thanks for watching.